Usually when we talk about display tech, we're all about the glass,
Yeah.
the 8K panels, the refresh rates, the things you actually see.
Hmm.
But today, I want to talk about the part that usually ruins that experience. We're looking at the NTI DP8K-FOCMP-25M-MM.
Catchy name, I know.
Rolls right off the tongue.
Hmm.
But look, it's a 25-meter DisplayPort cable that costs about $280. And I think for a lot of people, that just sounds insane.
Of course.
So the mission for this deep dive is to figure out, is this just an overpriced wire? Or is it actually, infrastructure?
It's definitely infrastructure. And to get the price, you have to understand the physics problem it's solving. We're dealing with 8K resolution here.
Which is just a staggering amount of data.
It's a huge amount of data. We're talking 32.4 gigabits per second.
That's the HBR3 standard.
Exactly. So now try pushing that much data through a normal copper wire for 25 meters.
You can't.
You just can't. The signal degrades, you get weird artifacts,
Yeah.
or the screen just goes black.
Right. And that brings us to the first spec that stood out to me. The documentation calls it a hybrid active optical cable.
Mm-hmm.
I think hybrid's the key word, because normally fiber needs its own power supply, right? Like a separate plug.
That's the one. Pure fiber optics can't carry electricity. But this NTI cable is pretty clever. It actually has copper cores inside just to pull power from whatever device you plug it into.
So no wall plugs.
No wall plugs needed. But the actual video data that gets converted into light pulses and sent down the optical fiber.
So you basically cheat the physics of copper by just switching to light.
You completely bypass the problem. Light doesn't face resistance like electricity does. That's why this unit, even though it's 25 meters, the tech itself can go up to 100 meters with zero loss.
Wow.
You get perfect 8K at 60 hertz, or 4K at 120 at the other end.
Okay, so that covers the performance. That makes sense.
Mm-hmm.
But there's another word in the name that points to a different kind of justification. It says it's a plenum cable.
Ah, yes. This is crucial if you're installing this in, say, a commercial building.
Or a high-end home theater, I imagine.
Exactly. Plenum just refers to the CMT rating on its jacket. It means the plastic won't release toxic smoke if there's a fire.
So you can legally run it through air ducts and ceilings.
Correct. You run a cheap cable through an air return, you're violating fire code. This thing is built to be buried in the walls. And that leads to another benefit. Noise immunity.
RFI and EMI.
Radio frequency and electromagnetic interference. So if you're in a hospital, for example, running a cable to a surgical display.
And medical imaging is one of the listed use cases.
Right. You might have an MRI machine nearby, which puts out huge magnetic fields. With copper, you'd get static, but light. It couldn't care less about magnetic fields.
So you get a clinically perfect image.
A perfect image, every time.
Speaking of a perfect image, though, we do have to talk about the limits. Even with this tech, you still run into the ceiling of the DisplayPort standard itself. I found this note about a specific Dell monitor really revealing.
Oh, the Dell UltraSharp UP32-18K.
That's the one. The notes say that for that monitor, one of these cables isn't enough. You have to run two of them.
In parallel, yeah. It's a great reality check, isn't it? That monitor just pushes the absolute limit of uncompressed data.
So it needs two highways for all the traffic.
It literally needs two lanes. I mean, it supports compression, DSC 1.2, but some of those early 8K screens just needed all the raw throughput they could get.
It really puts that 32.4 gigabits number in perspective. We're moving so much data, we need two fiber optic lines just for one screen.
And that really shows you this isn't just a cable, it's a core component. It's about future-proofing, whether it's for digital signage, or a broadcast station, or a flight simulator.
So that's the takeaway for you listening. The next time you see one of those huge, flawless digital displays, don't just look at the screen. Think about the invisible, high-tech optical highway hidden in the ceiling that's making it all possible.
It's the unsung hero of the whole setup.